So we said now the next step is to continue the forward elimination for the following terms. Okay. So first we will start by this element. This element is A prime. So already it was modified already in the first step. This is why it's called A prime 3, 2. And now I can define the factor F to eliminate it, F32 as A prime 3, 2 over A prime 2, 2, which is now the pivot element. This is A prime 2, 2, which is 7 over 3. So now I defined my factor, which is equal to 3 over 7, 3 over 7. And then what I will do is I will find the updated coefficients here. Okay. So of course, I will update now my coefficients. هلا هيدا الزيرو حيضله زيرو. You can try it بس حيضله إجباري زيرو. إذا تغير بيكون في شيء غلط. Why? Because already this is zero, and if you apply the formula يعني zero minus the factor of 3, 2 times the element in the pivot equation in the same column اللي هو already zero from the previous step. This is why no need to check for this one. أكيد حيكون zero. And this one also you can do it just for verification إنه حيطلع zero. So just you should see what will be the updated elements 1, 4, 2. Okay. So now 1 for example شو حتصير؟ حتصير 1 minus ال F32 هو 3 over 7 times this term اللي هو 7 over 3 حتطلع 1 minus 1 حتطلع 0. Okay. Now this element will be updated حيصير 4 minus 3 over 7 times this element اللي هو minus 7 over 3. So we get the updated value, the updated coefficient. وشو بنسمي ال updated coefficient? Because هيدا already كان اسمه, so this term let's say for example this one is can A prime 3 4 يعني ال updated one هيصير A second. This means انه it was changed for the second time. A second 3 4. Okay. And finally this will be B second 3. Okay. شو حيصير B second 3? B second 3 will be equal to B prime 3 minus F32 times B prime 2. Okay. So I will replace this term by this is 2 can equal to 2 minus ال F32 اللي هي 3 over 7 times for B prime 2. Okay, I have minus 5 over 6. Okay, so now what we will do now is that we will just update the values, okay, to get the updated matrix. So now if we just replace the updated coefficients, so as you can see here, this is a detailed calculation to update the elements. Okay, once we are done with this element صار عنا ي 0 and we updated the coefficients here, we will move to the last element in the second column. So this one also should be transformed to 0. This is why now, since the term to eliminate هون هو A prime for 2, then I should define F for 2 as minus 1 over 3 over the pivot element. Okay, so you will get then F for 2, okay, which is minus 1 over 7, and then you can update in a similar way the coefficient. So you will get A second for 2, A second for 3, A second for 4, and B second 4, which will replace. So هون مثلا minus 1 over 3 اللي كانت minus 1 over 3 حتصير 0. And as I told you, this step is just for verification. أكيد حتطلع 0 لأنه نحن we used F4 to any way to give us 0 here. Now ال2 الفاليو اللي كانت 5 over 3 حتصير الابديتد one هي 2. I will put 2 here. A second for 4 اللي كانت 7 over 3 حتصير 2. وال 5 over 6 حتصير B second 4 حتصير 5 over 7. And now we are done with the second column. صاروا 0 0. Once you are done with the second column, then you say that the second equation is locked. يعني as we did in the previous step. It's locked. I cannot use it anymore. So now my next pivot equation هتكون the third equation. بس هنشوف إنه we cannot take it as pivot equation لأنه ال pivot element هيكون 0. So إجباري نعمل pivoting. Okay. So let us see it here. So after eliminating the terms bال second column, we are done. We say that we will move now to the third equation as pivot equation, and our purpose will be to do the forward elimination of this term. بس لاحظوا شو عنا ال pivot element. The pivot element is 0, so if we don't do pivoting, the solution will fail because we cannot divide by 0. So now the last step will be to pivot these two rows. And when we pivot these two rows, we are done. And already هيدا 0, يعني we don't need to do any further calculation. So if you look at your updated matrix, so as we said, the pivot element here is 0, which is unacceptable. So we should pivot rows 3 and 4. Once the pivoting operation is done, this will be our matrix, and we are done. We are done with the forward elimination step. We reached an upper triangular matrix where all elements below the diagonal are zeros. Okay, and once you are done with this step, the next step is very simple. Okay, because now you will do backward substitution. So you will move now to the solution stage, the backward solution step. Okay. So first, before just moving to the backward substitution, we have a technique to find the determinant of the updated matrix. يعني انتو, we started by a full matrix, if you remember. Okay, we started by a full matrix, and we said that because the determinant of full matrix is hard to find, we come up with the Gauss elimination technique. Okay, so now we will see a relation between the determinant of the upper triangular matrix and the determinant of the full matrix. First, whenever you have an upper triangular matrix, the calculation of the determinant is very simple. The determinant is calculated as the product of the element on the diagonal. So for example here, for this matrix here, the determinant will be 6 times 7 over 3 times 2 times 5. Okay, now in case you do naive Gauss elimination, you can say that the determinant of the full matrix is equal to the determinant of the resulting upper triangular matrix. On the other hand, if you do Gauss elimination, they will be equal in magnitude, the determinants, but might have opposite signs. So the general rule to find the relation between the determinant of the full initial matrix and the final upper triangular matrix is the following. The determinant of the upper triangular matrix is given by A11 times A prime 22 times A second 33 times A third 44. So you can see here إنه ال A11 هي الوحيدة اللي ما تغيرت, بتضلها هي ذاتها لأنه هي ال pivot element, هي أول pivot element. And once we are done with the forward elimination of the terms of the first column, we lock the row. يعني هيدا ال A11 هيضل هو ذاته. بينما ال A prime, ال A22 will be modified one time. The A33 will be modified 2 times. This is why we put A prime prime. And A4 will be modified 3 times. لأنه كل ما نعمل forward elimination, ال A44 حيتأثر بالforward elimination للrow. Okay, يعني أنتوا هيدي الrow 4 حتمرق ب 3 levels. أول مرة when we did substitution لل A41, صح؟ تاني مرة حتتغير ال coefficients تبعها لما عملنا ال forward elimination لل A prime for 2. Okay. And ال third time حتكون لما نعمل transformation لل A prime prime for 3. This is why here ال A for 4 حتكون 3 prime. Okay. Now this will give you the determinant of the, so this is determinant of upper triangular matrix, and we can see that to relate it with the determinant تبع الفول matrix الأول شيء اللي بلشنا منه, we should know the number of pivoting operations. يعني if we here for example in this example we did the rows were pivoted 2 times. So if the rows are pivoted an even number of times, the determinant of the full matrix بيكون equal للdeterminant of the upper triangular matrix. If we pivot an odd number of times, يعني لو كانت 3 or 5 or 1, then بيصيروا opposite sign. بيضلوا same magnitude بس بيصيروا opposite sign. This is why the general rule that will give us the relation between the determinant of the initial matrix and determinant of matrix A of coefficients is equal to the determinant of the upper triangular matrix اللي هو given by the product of the elements on the diagonal times minus 1 to the power p, where p is the number of times we pivoted rows. If it's an even number, the determinant will be the same. If it's an odd number, the determinants will have opposite sign. Okay. Any question on this? Okay. You will see that this chapter is very simple. You are learning a technique, and it's just you follow the technique and you get the solution. Now, maybe when we do the explanation, you might see that also Gauss is also complex, and I need to do several steps. It's right, but in order to judge the efficiency, we should, for the computer considers the number of operations to do. يعني مثلا كل ما اعمل plus او minus او times او division هيدي operation. Okay. هلا you are not responsible of knowing how we derive this because it's a little bit complex. يعني بتكون تعرفوا تكتبوا الالجوريثم to be able to count the operations. It's fine, you are not responsible of this, but just I want you to understand the analysis here. If we compute the order of operations needed for Cramer's method, it's nearly n plus 1 factorial. It's of the order of n plus 1 factorial. While if you use the Gauss elimination method, the number of operations is of order of 2n cube over 3. And if you draw the graphs, the number of operations, function of the number of unknowns you have, so here it's n by n matrix, you can see that higher is n, larger is the difference between the two. This is why I told you إذا عندكم 2 or 3 equations with 2 or 3 unknowns, then it's fine, you can use Cramer, it's not a complex method. But if you have a very high number n, higher is the difference between Gauss and Cramer's rule. This is why Gauss is much more efficient with respect to time. يعني ونحن بنعرف in computers one of the most important parameters هو time, the computational time. This is why it's important to develop numerical techniques that will result in reduction of computational time. And Gauss elimination is one of these techniques. Now we move to three diagonal systems. Three diagonal systems is a particular form of systems, okay, where we have the elements are on, we have all elements 0 except the diagonal. So except the diagonal, and if you want the line just, we can call it upper diagonal and lower diagonal. Okay, so it's a band of 3 diagonals which are different than 0, while all other terms in my matrix are zeros. And in this case, this system is of high advantage because for a computer, when it will see all of these zeros, then it will disregard them because they will not be part of the solution. They will not affect anything. So the number of operations the computer will do will be reduced a lot. Let us take it as an example here. If you want to solve this system, okay? If you want to solve this system, we have first, if we use the forward elimination technique. Here we don't do pivoting. Why we don't do pivoting? Because the structure is already very good. يعني we desire the structure اللي هي zeros everywhere إلا على هول البند قصيرة يعني. So in this case we don't do pivoting at all. We just do forward elimination. And the forward elimination is very simple. Why? Because look here, for example, here you just need to do forward elimination for this term, because all of other terms are zero. So you want just here to perform forward elimination for E terms, E2, E3, until En, okay? And when you do the forward elimination, also the coefficient to change will not be as much as the previous case, because you have a lot of zeros. For example, if you want to start with the elimination of E2, okay, what is the technique? This is E2 is A21, okay, and F1 is A11. So if I apply the rule of forward elimination, then I will say that E2 new, the new value of E2 is the old value, okay, minus E2 over F1 times F1, which will give me 0 as predicted. Now, when I perform the forward elimination, I should update these coefficients. فلا already هول حيضلوا zeros. Why? لأنه عندهم zeros above them. So ما فيهم مشكلة. And even G2 will not change لأنه في zero above it. بالpivot equation, the element corresponding to G2 will 0. And G2 will not change. Okay? So only what will change is E2 حتصير 0, F2 should be updated, and R2 should be updated. And it's very easy. The formula of forward elimination is as follows. F2 new is F2 old minus the factor, which is E2 over F1 times G1. Okay? While for R2 new, you have R2 minus E2 over F1 times R1. And now you will see that this will be repetitive. And now, if you want to proceed with forward elimination, you will go to E3. So E3 new will be equal to E3 old, E3 minus the factor, which is E3 now over, you will update the pivot element, okay? لأن pivot equation, when you work with the first column, كانت pivot equation this one. Now you are done with this one. أصلا هن already zero. مش هيك ما عملنا غير elimination for E2. So now you are done with this column. This line, this row is locked. So your new pivot equation will be updated. حتصير second equation. This will be your new pivot equation. And then هيكون pivot element F2. Okay? So you can write that E3 new is equal to E3 minus as a factor. شو هيكون الفاكتور؟ هيكون E3 over F2, okay, times F2. So you can verify no, it will be 0. And you should update now. You should update the value of the coefficients. يعني أنا E3 حيصير 0. I should update F3. You will see that G3 will remain as it is لأنه the element above it بالpivot equation هو 0. So G3 will remain as it is. So I will only have to update F3 and to update R3. So similarly, you can derive the same, يعني you can derive a general rule لأنه حتطلع كمان F3 new هتكون F3 old minus E3 over F2 اللي هو الفاكتور times the element and above it in the pivot equation اللي هو G2. So times G2. Okay, and now the same for R. For R3 new, for R3 new, you have it's equal to R2, R3, sorry, minus E3 over F2 times the element in the pivot equation just above it اللي هو R2. So now you can deduce a general way, a general formulation for any element. يعني إذا باخد Fi, okay, if I want to get a general relation, EI, when I do forward elimination, EI new will be 0. So EI new at any step will be equal to 0. Now, Fi new, okay, will be equal to Fi, the old value, minus the factor, which is, I consider EI over Fi minus 1, okay? So this is a factor. And I multiply by G I minus 1. Okay, so this is a general form that will give me Fi new at any step. Okay, and I can also come up with a similar relation for R2. So for Ri. So for Ri new, it's equal to Ri old minus Ei over Fi minus 1 times Ri minus 1.
دكتور I
Yes.
was كهرباء راحت بس آخر شيء ما سمعت إذا صار في general form أو شيء.
Okay, Karen, من وين? From which step?
وصلت لل G2 new معي.
Okay. Look, G2 will not vary. Why? لأنه element بالpivot equation بيكون 0. Okay, يعني أنت عم تعمل G2 minus الفactor times الpivot element اللي بالpivot equation in the same column اللي هو 0. فإذا G2 will not change. Okay, so G2 new, any Gi new at any step will be equal to Gi old, and it will not change. The only factors that will change in the E بيصيروا zeros لأنه you are performing forward elimination. The F they will be updated, and the general rule to update F هي Fi new, okay, هي ال Fi old minus الفاكتور اللي هو حيكون when you want to eliminate EI. شو حيكون الفاكتور؟ EI over Fi اللي قبله over Fi minus 1 times, okay, times now you multiply the factor by the element in the pivot equation just in the same column اللي هو G. يعني أنت إذا عندك when you eliminate when you want to update F2 you do F2 minus E2 over F1 times G1. When you want to update Fi at any location, Fi will be Fi old minus Ei over Fi minus 1 times Gi minus 1, while Gi will remain the same. And concerning Ri new, it will be equal to Ri old minus the factor اللي هو Ei over Fi minus 1 times Ri minus 1. Okay? If not clear,
Yes,
I can... Okay. So you can take now any example, any subscript, حيطلع نفس general, it will follow the general formulation. Any question on this?
دكتور هلا the most difficult case will be 4x4 أو بتجيبي لنا هيدي بس يكون فيها zeros.
Yes حسن انتم مهم تعرفوا التكنيك. اوكي انا اكيد ما حاعجب لكم شيء كثير طويل يعني. So 4x4 if you just know how to do it for 4x4 هوليك بيصيروا اهين. 3x3 اهين 2x2 اهين. So yes,
كله مثل بعضه.
maximum 5x5.
Deal doctor. Thank you.
Okay. Okay. So now, just let me, sorry. Okay. So now, if we proceed, we can see that having a three diagonal system will, if you want, will reduce a lot the time of computation. لأنه the computer will see that zeros, يعني, he will know the form and he will know that because of we have a lot of zeros, a lot of operations can be reduced. Okay, so in this way, once you find your upper triangular matrix, once you create it, then the backward solution will be very simple also. Okay, so this is an interesting type of systems where you have three diagonal systems, because they will help you in reaching a solution in a faster way. Okay, so you will have substantial computational savings. And you can face such type of matrices in a lot of engineering applications. This is why we went over them. Okay. So mainly, this is chapter 9. In case anything was not clear for you about it, we can repeat it together. Okay. Do you want to repeat any example or any idea in this chapter that was not clear for you?
دكتور
Yes.
بس كنت بدي اسالك بسلايد 44 هو لانه لما حضرت الريكورد
Okay. Yeah. 24. Yes.
يس هون لما قلنا انه نحن في سلايد 44
24 or 44?
44
Oh, okay. What's your name?
محمد
Yes, Muhammad. Okay, this is 44. Yes. Okay.
يس هون لما ب 3 significant figures قلنا وقتها انه 0.0003 اخذوه لانه في زيروز، بس مش المفروض انه هون تكون لانه يعني هيك تعتبر كفور، ولا لانه لحتى اقدر اخذها مع 3.
Okay, هلا هن هون they are considering انتبه، هلا هون هن ما قالوا 3 significant digits, they are talking about figures after the decimal points. Okay, يعني هن حددوا انه this computer can carry this number of figures after the decimal point. يعني they are counting in this procedure حيعتبروا انه هن حددوا لك the number of figures. This is why you can take 3 figures after the decimal point even if you have 2 here.
يس
Okay? بس لو عم نحكي ب number of digits the computer can store it, it's different.
اوكي،
Okay?
يعني الفيجرز اكثر كنمبر غير الزيرو.
Yes, كبعد الديسيمال point.
يس ثانك يو دكتور.
Okay. Another question?
دكتور بعدنا مأخرين عن session 9
لا
عن
سبقناها.
okay. Can I ask question?
Yes.
I sent a slide that I did not understand. Just a second, I sent it on the group.
Okay, it's in this slide or in this chapter or in other chapter?
No.
طب هلا I will respond. يلا I will go over it. بس حدا بعد عنده question on this chapter? Okay, in which chapter, Karen?
Adding two numbers. Maybe if you want, I can tell you the two numbers and we add them together.
Yeah. Okay. What are the numbers?
Chapter 4 دكتور.
Chapter 4?
ايه هذا اللي فيه الأرنز.
Yeah.
Okay, merci.
Let me open it from Blackboard one second. Okay, which slide, Karen?
Slide 24.
Yeah, just 1 minute.
Take your time. 29. 29 دكتور.
Okay, 29. Okay.
ايه انا عم بيطلع معي الايرور 0.00041. ليش؟ لانه we did times 10 to the power 1.
ايه مظبوط. انت look انت اللي عملتيه صح. هيدا لازم يزيدوا times 10 to the power 1. Okay.
اوكي دكتور thank you.
Okay. Any
Hi,
other question?
yes, I have a question on this one.
Yes.
لو نحن عم ناخد for example in this specific case لو عم ناخد it can store 3 digits instead of 4. So
Okay.
basically my question is كنا أخذنا نحن يعني ال 7 plus
طيب.
3 كيف exactly كنا تعاملنا معها؟ كنا جمعنا 7 plus 3 وزدنا 1 على ال 5
لا لا كانت ال 0.15 يعني انت هيدا النمبر ال 3 if you can just read 3 digits you will read these 3 يعني you will read
okay.
1.55 وساعتها okay you can transform in this form يعني بصير عندك 0.155 والother term بصير مجبور يعني هيدي times 10 to the power 1 فإذا the other term will be of the following form 0.004 something هلا كل الباقي you cannot read it okay يعني من بعد ال 0.004 you cannot read 341 فكمان هيدي times 10 to the power 1 so if you do الaddition هيطلع لك in this case 0.159 okay so if you want to calculate a round of errors you should subtract 0.160041 minus 0.159 times 10 to the power 1 بيطلع لك الerror and it will be higher أكيد in this case.
Yes يعني whenever we say we store 4 digits أو 3 digits نحن بنكون من الأصل the things that we're adding نحن هذا من الأصل اللي بنكون عم نشتغل فيهم مش the last answer.
أكيد مش last بالعكس yes بالعكس اللي بالأول هن الأهم okay and here you start with the largest number يعني مين أكبر بيناتهم this one you start with this one you start with this number okay and then once you determine شو هو الاكسبوننت يعني انت you write it in standard way 0 point something بما انه الاكسبوننت تبعه 10 1 يعني كمان هيدا لازم يكون 10 1 and then if you can read 3 digits هيكونوا 3 whole 3 for this number and these 3 for this number.
Okay, doctor.
Welcome.
دكتور
Yes.
بعد السؤال معقول في مرة كنا مثلا عم تقولينا إذا لاحظتوا ال percentage of the error نزلت مثلا divided by 5 يعني ال H we should diminish it by 5 ها إنه أي متى بعوزها
إذا forward okay
أو أنت بتحددي لنا اعملوا H هالقد واعملوا H هالقد
إذا أنا ما حددت لكم وأنتم عارفين تقريبا قد إيه بتكون الايرور فيكم تقرروا ساعتها قد إيه تحطوا ال H okay يعني انا عم اقول لكم in case انتم عم تعملوا هالبروسيجر تتعرفوا what is the next step to take فيكم تشوفوا الايرور اذا انتم هدفكم كانت 5% وبدكم تروحوا ل 1 فاحسن يعني دايركت لتكون سريعه ما تصيروا تعملوا شوي شوي فيكم دغري اذا عم تشتغلوا باكورد و باكورد او فورورد لازم you divide h nearly by 5 كمان اذا كانت central you can divide by 2 point something تقريبا.
Doctor?
Yes.
بس a question from the last chapter وقت تقولي لنا naive Gauss pivoting is not allowed.
Yes, naive Gauss no pivoting.
Okay.
Yeah. Thank you.
من هون اجت اسم naive يعني it's weak. Okay. لأنه
yes,
it can fail easily أو it can lead to high round of errors.
Yes.
Yeah.
Thank you.
Doctor?
Yes.
Just to make sure, نحن whenever we're saying إنه centered central method هي أحسن شيء. It's about the first derivative صح؟
أول شيء it's about عم نحكي عن derivative plus بدنا نحدد مش إنه in general it's better، بدنا نحدد ال h. يعني نحن شفنا إنه for h smaller than 1 it's better, for h larger than 1 it's not، لأنه هي of order h solution. يعني أنت إذا
Yes.
بقول لك h أكبر من 1 ساعتها لا ال backward وال forward أحسن، لأنه ال error
Exactly.
بتصير أقل.
Okay, بس بالنسبة نحن بس أنا my question is like نحن when we say that إنه إذا مثلا h is less than 1 it's better for the central method.
Yes.
We're talking about the first derivative مش
Yes,
باقي
yes.
الأشياء مش
لا ما
دايما.
نحن بس عم نشتغل على first derivative only. Yes.
Okay.
دكتور بس يكون عنا change in slope البايسكشن كمان منا منيحة.
لا البايسكشن يعني البايسكشن اقل وحده بتتاثر بهالشيء.
اوكي يعني as a plan B بنروح على البايسكشن method.
يس يعني اذا الاوبن ميثودز عم بيعذبوكم go to البايسكشن احسن شيء.
اوكي دكتور ثانك يو.
بس دكتور إذا كانت في inflection أو change in the slope ما
Yeah.
بتزبط كمان secant أو modified secant with big
لا
delta؟
السيكنت اضبط من الموديفايد، لانه الموديفايد بتكون قريبه من النيوتن راكسن، السيكنت بتصير احسن وحده بيناتهم ساعتها لانه بتبعد شوي عن الاكتوال تانجنت.
ودكتور إذا عملنا مثلا نيوتن وطلع معنا two errors اثنيناتهم عم بيكبروا فينا نتركها ونقول لك إنه ممكن slow أو diverge من دون ما نكفيها؟
نيوتن يس نيوتن عادة دغري بتبين، يعني إذا من الأول عم بتزيد خلص بدها تضل تزيد، بينما إذا كانت كبيرة لو كبيرة ونقصت يعني حتضل تنقص، بس it can be slow، بس once مرة عليت يعني حتضل تعلى. بينما هوليك نو يعني هيدا الجود about نيوتن راكسن، يعني دغري فيك تعرف if it will converge or not. بينما هوليك كان oscillate، هوليك الميثودز كان oscillate ساعة تزيد ساعة تنقص. نيوتن رافسون it's quadratic convergence، يعني أو دغري بتبين it will converge أو it will have two other possibilities، أو slow divergence أو slow convergence أو divergence.
Yes.
Any other question? Okay, good luck. Good luck for the exam. يلا study well. See you
Thank you,
at
doctor.
we will meet at 7:10. خلينا نبلش at 7:10 to make sure إنه all of you are there and everything is fine, so we can start then at 7:30 the exam. Okay.
Okay, doctor.
يلا bye bye.
Thank you, doctor. Have a nice day. Bye.
You too. Bye.
Thank you, doctor.
Yes, you can use a formula sheet during the exam. Of course you can.